Today we are going to start our mathematical journey. And math is its own language, and there is a lot to the language of math. There's a lot that we need to comprehend as we move through not only high school math, but college math and beyond. And so, as we begin our journey in Algebra 1, we have to set the foundation first of all, and that is to know what some of these symbols in math do and what some of these vocabulary words mean. And so, if you will go ahead and take out your note sheet for this particular concept, which looks like this, the first thing we're going to do is we're going to fill in some definitions for four basic vocabulary words. And so the first word that we have is sum. Now when we see the word sum, we need to understand that that means that we're going to do some addition in that problem. Our second word is difference. What does difference mean? Well, difference means that we're going to be involved with subtraction. When we see the word product, that means that we're going to do multiplication. And then our fourth item that we have is quotient. Quotient means we're going to do division. So you should have those four words written next to each of the vocabulary items, because now we're going to go ahead and use those vocabulary items as we go through some of the specific items that we're going to be dealing with in this particular concept. The first thing we're going to visit today is estimation. Now, when we estimate, we're going to round, and estimation is a tool used to give us, well, an idea, not an exact answer, but an answer that's close to what we're looking for. So we need to understand our places, and so the 4 is in the ones place, the 3 is in the tens place, hundreds place, and the 1 is in the thousands place. This 5 to the right of the decimal is the tens place, hundreds place, and the thousands place finishes things off. And so now we're going to round this number to the nearest hundred. So the first thing we do is find the hundreds place, which is the 2, and we look to the right of the 2. If the number to the right of the 2 is 5 or more, we round the 2 up to a 3. In this case, it's not, so rounding this number, 1,234 and 567 thousandths, to the nearest hundred would give us 1,200. So write that down below there. Now we're going to round the number to the nearest hundredth. So we find the hundredths place, which is the 6, and we look to the right of it. If we see the number is 5 or bigger to the right of the 6, we round the 6 up to a 7. And it is, so this number is going to round to 1,234 and 57 hundredths. Rounding to hundredths is a lot like rounding to the nearest cent. And so that's how we can use estimation and the tool of rounding if we don't want an exact answer. And just like that, a number line appears, because now we're going to talk about making comparisons. When we look at a number line, we can look at it in a way such that we've got 0 in the middle, and all the positive numbers are to the right, and all the negative numbers are to the left. When we make comparisons, we use two symbols, and this first symbol is the less than symbol, pointing to the left. The second symbol is called the greater than symbol. And we want to use those two symbols as we look to compare the four problems that you have on your note sheet. So first of all, negative 5.2 compared to negative 5.02. Well, on a number line, negative 5.2 is farther to the left compared to negative 5.02. Here's negative 5, and here's negative 6. So negative 5.2 would be right about there, and negative 5.02 would be just a little bit over. And so because of that, we can say that negative 5.2 is less than negative 5.02. So that's how we can compare two negative numbers. What about two fractions? Well, the first fraction we have on this next problem is 7/8. The second fraction we have is 9/20. Well, if we take a look at 7/8, 7/8 is more than half, because half of 8 is 4, and 7/8 is over half. Half of 20 is 10, and since 9/20 appears to be less than half, we can say that 7/8 is greater than 9/20. The third example has a square root. The square root of 36 is 6, because 6 times 6 is 36. So because we make that change, we see that the square root of 36 is less than 6.4. And finally, in our last example, the square root of 53. Well, that's not a square root that we know. But we do know this, that the square root of 49 is 7, and the square root of 64 is 8. So 53 is a little closer to 49 than it is to 64. Our answer has to be between 7 and 8. And so we're going to make an educated guess that the square root of 53 is about 7.2. Now, over on the right, 29/3. Well, that bar on that fraction means to divide. So 3 goes into 29 9 times, with 2 left over. So we have 9 2/3. Well, 7.2, approximately, is less than 9 2/3. And that's how we can compare any kind of number using those particular signs. Next, let's spend a moment talking about integers and their operations. Now, when we have sums of integers are positive, negative, or zero numbers that don't have a decimal or fraction along with them. When we have sums, like negative 14 plus a negative 9, we're going to go ahead and keep the sign, which is negative, and add the numbers, negative 23. If the signs are different, like negative 14 plus 9, we have more negatives than positives, so our answer will be negative, and we end up subtracting the 2, so that gives us negative 5 for our final answer. Differences, such as 7 minus 10, well, when we subtract integers, we're actually adding the opposite, so 7 plus a negative 10 is negative 3. For products and quotients, we follow the rule that if we have an even number of negative signs, the result will be positive, like negative 4 times negative 6 is going to be a positive 24. If we have an odd number of negative signs, whether we're multiplying or dividing, we're going to have a negative answer, like negative 70 divided by 10 is negative 7. Now the final thing that we want to look at is fractions and their operations. When we add and subtract fractions, what we want to do is we want to make sure we have a common denominator. And so getting a common denominator for 4 and 8, the least common multiple of 4 and 8 is 8. So we're going to change 3/4 into 8s by multiplying 4 by 2 to get 8, and 3 times 2 to get 6. And to that, we're going to add 5/8, which doesn't need to be changed. So 6/8 plus 5/8 turns out to be a sum of 11/8. And we can leave answers as improper. In fact, we'd like you to do so. Subtracting, same thing. We've already got common denominators, so 6/8 minus 5/8 is going to give us 1/8 for a final answer there. Now, when we multiply fractions, we don't need common denominators. But what we do want to do is we want to look at the numbers across from each other. And we want to look, is there any factor that divides out into 4 and 5? In this case, there's nothing. So we look at 3 and 8. Is there any factor that we can divide out of 3 and 8? Being none, all we do now is multiply across. And so our final answer for this one turns out to be 15 over 32. Now when we divide fractions, the first thing we have to do, and you might remember this from the past, is keep, change, flip, or we keep the first fraction and multiply by the reciprocal of 5/8, which is 8/5. And what we do again, since it's now a multiplication question, is we look at the 3 and at the 5. And do they have any factors in common? The answer is no. But we look at now the 4 and the 8. Well, we can divide 4 by 4, and that gives us 1. And if we divide 8 by 4, that gives us 2. So now we can multiply across. 3 times 2 is 6. 1 times 5 is 5. Our answer is 6/5. Our last fraction problem involves a whole number, 6. And when we multiply, we're going to change this 6 to a fraction, namely 6 over 1, and leave the 2/3. Since it's a multiplication problem, again, I need to look across. 1 and 2 aren't going to have any factors in common, but 6 and 3. You can divide 6 by 3 to get 2, and 3 by 3 to get 1. This gives us a final answer of 2 times 2, which is 4, 1 times 1, which is 1, which is indeed just the number 4. At this time, that concludes the notes section, and so this is the independent practice part of the video. And so there are 4 problems down below here, and I want you to take a moment, and this is the time where you would pause the video, do these 4 items, and then I'll be right back with you in a moment to share the answers with you before moving on. Alright, you're back, I'm back. Let's round this first one to the nearest tenth. The 8 is in the tenths place. We look to the right. The answer you should have for the first one is 504.8. The second problem, we have to put these numbers in order from smallest to largest. And so, the square root of 10. Well, we know the square root of 9 is 3, so this is going to be just a little bit more than 3, like maybe 3.1. Now 20 over 5 is the same as 20 divided by 5, which is 4. And so if we put these in order from smallest to largest, well, the smallest number that we're going to see is the square root of 10. The next smallest number is 3.094, followed by 3.9, and 20 divided by 5. And you might have wrote those numbers in a different form, but that should be the order of those. The third problem says product, and that means to multiply. So negative 8 times 5 is negative 40. Now we find the difference, which means to subtract on our last problem. So off to the side here, 7/16 minus a fourth. We need the least common multiple of 16 and 4, which is 16. So the top fraction will stay 7/16, but the bottom fraction will turn into 4/16. 4 times 4 gives us 16, so 1 times 4 gives us 4. We now subtract, and we only subtract the numerator, so that gives us 3 over 16. That concludes the notes and the practice in the video right now. And so your next step is now you're going to get a teacher talk over this concept. And so that's going to make sure that you have a good foundation on this concept so you can go ahead and proceed to the practice. Hey, we'll see you next time. Thanks for listening. Thanks for following along. Good luck with this concept.